I'm going to show you uh my, second. I have five girls as my beautiful girls. So um one is going to be graduating in May this year. She's attending Winona State University. Has anybody heard about Winona? She studied nursing. And I have the second one, Aliyah. She's into track. She just secured a full scholarship to University of St. Thomas. So the third one, Simbi is a freshman in high school, and the fourth one is Azizat in middle school, and the last is Wendy in elementary school, fifth grade. My wife and I, we have been statistically busy. So yeah. So I have a PhD in mathematical statistics. My area in statistics is into development of statistical models, robust statistical models. So in case there's a violation of assumptions on the line or the use of model, or what do we need to do parametrically, that is what I've been doing. I also do some research in machine learning, multivariate analysis, and so on, like that. So, of course, this lecture, I believe you're all for 5401, right? Okay. So this applied multivariate analysis. Of course, I plan to have office hour on Zoom. I want to conduct that remotely. I want a situation whereby you can be anywhere in the world to attend my office hour. So I'm actually going to say this. Make sure you reach out in case you get stuck. I believe in one, according to a philosopher, a problem disclosed is problem solved. So let me know what you're going through in terms of whether you get stuck. Of course, you can trust me, and whatever we discuss, will be treated with absolute degree of confidentiality. Okay, so this is the venue of the lecture, 212. I think initially when I was communicating with you, I put 221. So it's not 221. It's actually 212, this particular venue. Okay, so I think I've shared the electronic copy of the textbook for this course, which is Applied Multivariate Statistical Analysis by Johnson and Wishen, 2007. I will advise you download the electronic version of this because most of the assignment questions will be coming from there. And before moving forward, I think you've heard about me now. I think I just need to meet you. Just need to tell me your name, what you major in, and we want to make it so fast. I'm actually going to start from here. So, can you tell me your name and what you major in? You're welcome. Yep. Okay. You're welcome. Thank you so much. Yep.
Data science.
Thank you so much for sharing that. Yep.
My name is Noah. I'm a master's in data science.
Thank you so much. I think I've seen most of you before. And today, yep.
My name is Dina, and I'm also majoring in data science.
You're welcome to our meets. Yep.
I'm Mara, majoring in statistics and economics.
Statistics. I hear super course. Yep.
My name is Ani, and I'm majoring in data science.
Thank you for coming. Yep.
I'm Maya.
Thank you.
I am Colleen and I'm a second year PhD in psychology.
Okay. Thank you so much.
I'm Leah, statistics.
Thank you.
I'm Daksh, data science.
Thank you so much. Yep.
I'm Johnny, I'm in statistics and economics.
Thank you so much.
I'm Deviana.
Thank you.
Player development psychology and
Thank you so much.
I'm Arthur, I'm a master's student in data science.
Thank you so much. Yes.
I'm second year PhD student in marketing.
Thank you so much. Yep.
I'm Cindy. I'm data science.
Thank you for coming. Yep.
I'm Anna, PhD student in psychology.
Thank you. So,
Yeah. My major is statistics.
thank you.
I'm Carter. I'm in data science.
Thank you so much.
I'm Blake. I'm industrial engineering.
Thank you so much. Yeah,
I'm Carter and I'm majoring in data science.
thank you.
I'm Roman. I'm a senior data science student.
Thank you.
I'm Samad, I'm masters in data science.
Thank you.
I'm looking for statistics on the minor in data science.
Okay, thank you so much. Yeah,
Yeah.
thank you.
I'm Daniel, I'm in data science.
Thank you.
I'm Ram and I'm master student in data.
Thank you so.
I'm first in data science.
Thank you.
We have in data science.
Huh? Can you say that again?
Data science.
Oh, okay. Thank you so.
I'm Vishwa, I'm also a data science student.
Thank you.
I'm major in applied statistics and minor in computer science.
Thank you so. Yep.
I'm Maxwell. I'm majoring in stats.
Thank you.
I'm Arnav. I'm doing data science.
Thank you.
I'm Karina, I'm in sports management.
Thank you for coming.
Thank you, no, I'm statistics.
Thank you.
Yeah.
Thank you.
I'm majoring in data science.
Thank you.
I'm studying data science.
Thank you so much.
Jordan and I'm
Thank you. Thank you.
I'm Jack and I'm doing data science.
Thank you.
I'm Colette, I'm doing actuarial science and statistics.
Thank you so.
I'm Jing Xu. My major is econ stats.
Thank you.
I'm Farhana, masters in data science.
Thank you.
Catherine, statistics and economics.
Thank you.
My name is Branda, I major in stats.
Thank you.
My name is Krishna and I'm major data science.
Thank you.
Buona master.
Thank you.
Gregory, I do computer.
Thank you.
I'm doing
Thank you.
Chelsea, my major is statistics.
Thank you.
James, computation file.
Thank you. Thank you. Thank you so much. I think some student just walking. If you just and if you know you don't introduce yourself, can I see you? Okay, yep.
My name is Mina and I'm doing a major in statistics and a minor in computer science.
Okay, thank you so much. Okay, is there anyone who has not introduced either herself or good, right? Okay.
Midterms and our final. And of course, this is what I normally do out of the nine assignment. Okay, I'm only going to use eight. I'm going to drop the assignment you have the lowest score. But I will advise you to put in effort, making sure you have a perfect score, so which is possible in the assignment. Assignment will be posted every Sunday night and actually going to be due the following Sunday night at 11:59 p.m. Of course, I've instructed my TA to make sure results are released latest Wednesday following the deadline. Okay. And of course, we're going to have midterm one, we're going to have midterm two, and we're also going to have final. And of course, I'm actually going to release practice questions, whether for midterm one or midterm two or the final ahead of time. And of course, I'm going to walk you through that before the exam. We're going to discuss what are the possible areas, that you're going to be expecting in the exam and how you are expected to answer questions in the exam. Okay, now I want to come to the course right now, but before going into the course, um, this is where we find yourself studying anything that is statistically related. Let me just tell you the way I understand my statistics. Before going into that, I don't know if I told you I have a PhD in mathematical statistics, and of course um I think I joined the services. My first time in teaching at the college was in 2010 or 2010, 15 years ago, or so 16 years ago. And of course, I joined the services of the School of Statistics, University of Minnesota in 2018. Of course, this is my 8 years, at this university. I'm also an assistant director for the graduate studies. Um, but let me tell you this, going into this course, okay, this course is applied, and I want you to follow this course with your practical mind. I'm going to say that again. You need to follow this course with practical mind. Let me tell you this, even though we're going to have some equations, we're going to have some formula, but let me tell you this, what I will advise is for you to try to understand what each notation stand for, what each symbol stand for. I understand my math, I understand my statistics because I actually pay attention. I always want to understand what is behind every equation. There's always a story to tell. If you understand the story behind every equation, every notation, you're actually going to be fine. So follow this course with practical mind. And another thing I'm actually going to say before we get started, okay, is that you should believe in yourself that in this course, your target is A, which is possible. Along the line, if you actually get stuck, it's understandable if anybody can get stuck, but when you get stuck, make sure you reach out. And you know what? If you get stuck from day one, make sure you reach out immediately because topics are kind of related. The moment you get stuck in one and you don't figure it out, there's possibility or there's high chance somebody will keep getting stuck. So which means that we advise you to approach it one at a time. Is there any question from anybody before I start the first lecture in 2026? Do you know this is going to be my first class in 2026? So, or is there anyone? I remember when I stepped into this country in 2016. The first question when I step into a class, and the first question I asked from students, do you understand the way I talk? Is there anybody in this class who doesn't understand or who actually struggle with my accent or with the way I talk? Be sincere. Is there anyone in this class? You know, I want to be statistical in talking. I don't want to rush. And I don't want to be slow in talking. I want to find myself in the middle. But in a situation where you are not getting the way I talk, because I know communication is the key. The moment you don't get what I'm saying, that is more or less like a noise. I don't want to make a noise. Okay? You are good, right? You all understand what I'm saying, right? Now, let's get started. Are you ready? You ready, right? Okay, let's get started. Okay. Now, I want to introduce you to multivariate analysis. If I go into a course, from the title, I really want to understand what the course is about. It's a multivariate analysis. The very first question I'm going to ask myself, why do we need to do multivariate analysis? Okay. And another question I'm actually going to ask myself, what do I stand to benefit from learning this course, and what did the society stand to benefit? I'm going to say that again. I want to introduce you to multivariate analysis. And the question is, why do we need multivariate analysis? And what do you stand to benefit, learning multivariate analysis? And because you are not only learning for yourself, you're also learning for society. Okay, what do the society stand to gain from the, multivariate analysis? Now, let me tell you this. I'm going to give you the story before we come into this. The story is this. Okay, as human beings, we want to understand the world. As human being, we actually want to be in charge. We actually want to make, before tomorrow, we actually want to make a prediction of what is going to happen. Why do you think we get worried? Why do we think we are anxious to know the future? Why do we think we are always worried to do that? Because we live in a stochastic environment where things are changing. Let me tell you this. If things stay the same, we do not have any cause to worry. For instance, if I know every day I'm going to smile, then I'm not going to worry about whether I'm going to smile or not tomorrow. But that is not going to happen in this kind of environment where there's variations. Okay, different things happens in different days. And because of that, we get worried. We now want to make a prediction of what is going to happen next. Well, we also want to understand why things happen and so on like that. For us to be able to, if we want to have that kind of understanding, we need information. Okay, we need knowledge. Now, I need you to pay attention. Okay, as human being, we actually want to understand our environment. When I say environment, we want to understand our medical environment. I want to understand our economic environment. I want to understand my political environment. I want to understand my environment in general. If I want to understand my environment, I actually need, knowledge. Okay, I need knowledge. Okay, I need knowledge. Okay, to be able to understand my environment. Okay, where would the knowledge come from? Okay, the knowledge is going to come from information. Okay, so you are here now. You actually want to get some statistical information, right? Okay. And when you get the information, then you have the knowledge. And when you have the knowledge, then you'll be able to understand your environment. Okay. Where will the information, okay, where will the information come from? Okay. So the information is actually going to come from data. Okay. Now, I just wanted to take a look at this. Okay. Let me do this. Okay, you can see this particular connection. Okay, I need knowledge to understand my environment. And where will the knowledge come from? The knowledge going to come from information that I got. Where will the information come from? Information is going to come from data. And let me tell you this. And that is why we want to start with data, okay? Because we believe the information that we're looking for is hidden in the data. I'm going to say that again. The information that we're looking for is actually hidden in this particular data. And let me tell you this. Uh, if I want to get information from data, but then I actually going to make use of a model. Okay. I'm actually going to make use of a model. Okay. We're going to use model. Okay. To analyze our data. Okay. With an attempt to get information. But let me tell you this. Okay. Even if I use the best model, we're never going to get 100% information in the data. I'm going to say that again. When I use the best model, okay, the best model cannot extract 100% information in data. There's always going to be information loss. I just wanted to know that. Okay, we acknowledge the fact that there's going to be loss of information, but we actually want to minimize that loss of information. Okay, so now let me tell you this. So like I said, we're going to use model to extract information from data. Also, which means, in a way, what model means, a model is a mathematical or statistical representation of reality. We want to use model to represent reality. But let me tell you this, model is not going to be the same as reality. The reason why model is not going to give us exact reality is because there's always going to be loss of information. Okay, so model is not the same as reality, but model will give us an approximate reality. We're okay with that. Okay, now if it means if I want to start, I'm actually going to start from data. If I'm going to start from data, okay, then the type of model that I'm actually going to use now depends on data. We got different kind of data. Like in this course, we're going to be making use of multivariate data. Okay. When I say multivariate data, what do I mean by multivariate data? So what I mean by multivariate data is I'm actually going to collect data over so many variables. Okay. When I say so many variables, for instance, maybe I want to talk about crime. I want to talk about crime variables. Okay, if I want to talk about crime variables, or maybe I collected data from different neighborhood and across crime variables, like maybe I want to talk about violent crime, property crime, the unemployment, and so on like that. So the moment you have more than, if I have one variable, if I'm only interested in one variable, I call that univariate. If I focus on two variables at a time, I call that bivariate. But if I have more than two variables, I'm actually going to call that multivariate. So in this course, we're going to make use of multivariate data. Does that make sense? Okay, now I'm going to have introduction, of course, which I've already done. Application of multivariate analysis. Of course, you only perform multivariate analysis on multivariate data. Okay, now we're going to talk about how we organize our data, okay, for analysis. Okay, we're going to talk about the use of data matrix. We're going to talk about descriptive statistics, and we're also going to talk about how we visualize our data set. What are the tools that we use in doing that? Okay, then we're going to talk about the distance between objects. Now, I think I want to introduce you to multivariate analysis. Now, let me tell you this. You know, you all know our intention. Our intention is actually to uncover the hidden information in data set. And right now, we got multivariate data set. The multivariate data set. Now, let me tell you this. You know, some of you may be wondering, what is the difference between high dimensional data and a big data? Okay, so here in multivariate analysis, we could work on big data, we could work on high dimensional data, but let me tell you this, the multivariate analysis situation where you collect your data across so many variables, then your data qualify to be multivariate data. And when you have a multivariate data, then you're actually going to use multivariate analysis. Now, let me now tell you this. When I say multivariate analysis, this is when we actually want to analyze simultaneously so more than two variables, and with the intention, you know, to uncover a complex pattern. Okay, we believe there's a kind of pattern when I have so many variables that are related or that are jointly related. I actually want to figure out the pattern, and of course, to be able to do that, okay, we're going to use multivariate analysis techniques. So now in multivariate analysis techniques, there are so many techniques, but let me tell you this. The type of technique we're going to apply depends on our intention. Okay, what do we want to achieve? And not only that, the nature of data. The nature of your data set will determine the technique of statistics you're actually going to apply. We don't just do what we do. There's a reason why we do what we do. Okay, we want a situation where if I want to apply a particular statistical method, I'm going to look into the nature of the data set that I have, because you know, there should be a kind of agreement. There should be agreement between the nature of the model, the technique I want to apply, and the nature of the data. They have to agree. If they don't agree, you may not be able to bring out a meaningful information in the data set. I'm going to say that again. The nature of the data set and the nature of the technique of statistics, they have to be in agreement. If they don't agree, then you are not likely going to extract meaningful information. Now, so in general, when I talk about multivariate analysis, of course, I'm actually referring to the technique of statistics that we apply to multivariate data set. And I say multivariate data set, of course, so we are collected data across so many variables, and those variables are related, and they actually jointly influence an outcome. And instead of us to study them in isolation, some of you may be wondering, why am I interested in multivariate? Why not just analyze the variable one at a time? When you analyze the variable one at a time, please, I need you to pay attention. If you don't understand, ask me question. When you analyze the variable one at a time, we are doing univariate. And when you analyze the variable one at a time, you are ignoring the potential correlation that may be among the variables. I'm going to say that again. Why not choosing to analyze the variable one at a time? Why do I need to go for simultaneous analysis of these variables? Is because when correlation exists among variables, when you try to analyze the variable one at a time, then you are ignoring that correlation. When you are ignoring that correlation, then at the end of the day, your model will mislead. And that is the reason why when relationship exists among variables, okay, it's a very good idea to simultaneously use a multivariate technique and analyze them together. Does that make sense? Okay, now, in most studies, we normally, like I said, before you go, analyze data, you collect your data. And when you collect your data, okay, the data actually going to look like a form of a matrix where you collect data across observations and across variables. Does that make sense? You have observations and you have across variables, and of course, in the variables, you could have some variables could be explanatory variables, and one of them would be maybe a response variable. Okay, in a situation where you also have a response variable that I call outcome variable in your data set, then the approach in the multivariate analysis we're going to use will be called a supervised learning. Okay, we actually be called supervised. Actually, it's going to be supervised learning because we have a response variable. Why? We have an outcome variable. But what if in a situation where we do not have a response variable? Among the variables, we do not have outcome variables. Among the variable, of course, we're going to be talking about unsupervised learning. So when you talk about multivariate analysis, okay, we normally put into consideration the nature of the variables we have. Do we have in this set of variables, do we have an outcome variable? If we have an outcome variable, we actually talking about supervised learning. We're going to use the techniques under supervised learning because we have an outcome variable. But situation where we do not have an outcome variable, we only have a set of explanatory variables that we're going to be talking about unsupervised. Let me tell you this. Statistician or researcher to a data relationship they have is synonymous with the relationship a physician and a patient. Because before a patient can actually successfully treat a patient, before a physician can successfully treat a patient, that physician must understand everything about that very patient. The same thing with researcher. When you're working with data, okay, if you don't want to mislead, if you want to apply the right statistical technique, you need to be able to understand all of this, like the nature of your variables. Do we have a response variable here? We do not have a response variable, and so on like that. And that's what I said. We could have a multiple explanatory variable. We could also have a multiple response variable. We could also have situation where we collect the data in more than one location. Okay, when you collect data from the same person in more than one location, we call that kind of data longitudinal data. Okay, longitudinal. And the approach that we're going to use will be different from when you actually collect the data in just one occasion. Okay. Now, I just wanted to see that. But let me tell you this. In multivariate analysis, with this possibility, we're going to see more than one response variable, more than one outcome variable, where we can simultaneously, explain effects of some variables, or not only one response variable, even more than one response variable. Okay, now another thing that I'm actually going to talk about, what is our interest? Our interest is if I have so many variables, there's possibility they could be related. And when they are related, can we have a way to explain that relationship? We are interested in doing that. And that's why I said we want to understand similarity. We want to understand differences in the variables. And not only that, we really want to investigate the association. Let me tell you this. Two variables may be associated, but that doesn't mean one causes the other. There's a difference between association and causation. Okay, we're going to talk about that in this course. Okay, now we're going to see whether they are associated or not, and not only that, the structure, we'll be able to understand the structure of the variables. Okay, so that is our interest. Let me tell you this: we got intention from the beginning. We don't just do what we do. We got reason why we do what we do. I told you we need knowledge because we want to understand things, right? And knowledge is going to come from information that we got. And the information is actually going to come from data. But you know what? Uh, when I collect data set, the information that we need is not readily available. Something needs to be done to the data. And what needs to be done to the data is actually to confront the data with an appropriate statistical model. Look, I'm going to say that again. Appropriate statistical model. Why do I say appropriate statistical model? You will be able to do that if you understand the nature of your data, if you understand the kind of variables you have in your data, then that, and with your intention, then you'll be able to know what method of statistics you're actually going to apply. Is there any questions so far? Today is more or less going to be an introductory, or we are on introductory stage, very crucial stage. The moment you understand, the background, if you get the background information, or you should be fine. Now let's talk about the objective of multivariate studies. Why am I wasting my time, or conducting research or multivariate analysis? We don't just do what we do. The number one reason why we do that, I need you to pay attention. The number one reason, one objective in multivariate analysis, don't forget, in multivariate analysis, before you can apply multivariate analysis, it means you got multiple variables. And let me tell you this, when you have multiple variables, interpretation is going to be an issue. I'm going to say that again. Because if you got so many variables, interpretation will be lost. And you know what we need to do? We need to have a way to reduce the dimensionality in our data set, because when you reduce the dimensionality in the data set, okay, then the interpretation can be improved upon. In statistical analysis, we want to have a situation whereby our model will be reliable, our model will be interpretable. Okay, and for us to guarantee interpretation in a high dimensional data, when I say high dimensional data, you got so many variables, and those variables are related. Okay, when they are related, they may be given the same statistical information. That we need to be able to apply an appropriate statistical methodology that can reduce the dimensionality in the data set. Okay, when I reduce it, let me tell you this: when you reduce the dimensionality in the data set, you're losing information. But we actually want to use a technique that can guarantee, that will be able to preserve, essential information, even though there's going to be information loss. And in this course, I'm actually going to walk you through what we call the principal component analysis. With the principal component analysis, that is one of the dimensionality reduction technique. I'm going to give you an example. I understand my statistics, by citing example. Let's go practical right now. I want to go into crime. Okay, if a police department collects variables, maybe across neighborhood, and maybe they actually have 15 related 15 crime related variables. The crime related variables, like number one, I want to talk about the burglary rate. Maybe they have the burglary, but the burglary rate, the assault, robbery robbery, okay, population density, and so on like that. Population density. So let's say we have like up to 15 variables. Okay, if I get so many variables that are related, okay, I'm actually going to believe there's going to be interpretation loss. Whenever you got so many variables, interpretation is not going to be easy to make. But in this course, I'm actually going to walk you through a technique of multivariate analysis that we call PCA. Okay, PCA, principal component analysis, that will enable us to reduce the dimensionality. Instead of first working with 15 variables, we're only going to work with 3 variables, maybe 2 or 3 variables, and those dimension will be new. So maybe I can talk about crime intensity index, crime intensity. Maybe I'm going to talk about crime intensity index. Okay. Uh, police efficiency, efficiency index. Okay. So on like that. So now, maybe some other. So instead of me to work on all of these variables, the principal component will enable us to have what I call the artificial. We're gonna have artificial dimensions, a fewer artificial dimension. Let me also social vulnerability index. Okay. Now this will be interpretable when I have a reduced dimension. Okay, so we're going to talk about. So that is what I mean by data reduction or simplification. Let me tell you this. The data that you collect is massive in nature. They may not be able to make sense, when you analyze them the way they are. So, and that's why we need simplification. So with simplification, with technique of data reduction, we can guarantee interpretation. Is there any question on that? Okay, I'm actually going to go to the next one, sorting and grouping. Okay, I may want to group in the maybe cities into different categories, maybe in terms of intensity of crime, and that is why you're actually going to see police vehicles patrolling some city, more than some city. Okay, so maybe that particular city is actually grouped into high density of crime. And let me tell you this, before I can talk about sorting and grouping, then I should be working with unsupervised learning, because we do not have an outcome variable. We only have set of independent variables. Okay, so based on certain characteristics, okay, we can actually group. For instance, let me go into court. Now, somebody was pronounced guilty, and I want to believe before sentencing, the judge uh they're going to consider what I call some aggravating, as somebody had about aggravating factors before sentencing, or maybe somebody applied for parole, and the judge will put into consideration what is the probability of this particular person reoffending. They're going to put that into consideration. Or even in hospital, before the charging patient, before doctors will certify that, oh, this patient is good, they have to consider the probability of readmission, okay, based on certain clinical variables. Let me tell you this. I told you, I told you before, if you really want to understand what we're doing, try to relate to real life. Give example. You're actually going to be good. Now, I want to go into investigation of dependency. You know, when I talk about dependency, okay, we actually want to know how a particular variable explain or causes the other. Okay, you know, and that's what we mean. You know, some variables may depend on some other variables. I think I gave some uh you know examples on that. You know, if I want to consider two major variables, for instance, I want to talk about dependency. Please pay attention. I'm on investigation of dependency. Okay, dependence. Okay, number three. We are still on the objective of multivariate analysis. Okay. Now, we have, let's say we have two major variable, crime variables and socio-economic variables. Okay. Now, in the crime variables, let me give an example so that you can be precise. Here I have violent crime. Okay, violent crime, property crime. Okay, property crime, drug offenses, and of course, in socio-economic variable, I have poverty, okay, education, and unemployment. Let me tell you this. When I was talking about data reduction in this class, we're going to learn some techniques for dimensionality reduction, like principal component analysis and so on like that. When I was talking about sorting and grouping, we're going to learn a technique called cluster, okay, clustering, okay, in this class. Now we are on investigation of dependence. And of course, in this class, we're going to learn a technique called canonical correlation, okay, canonical correlation, canonical correlation analysis, okay, that we also call CCA. Now, in canonical correlation analysis, we can actually use that to investigate dependence between two variables. But let me tell you, when I say two major variables, each of the variables has some variables. Take a look at this. If I was talking about crime variables and socioeconomic variables, under crime variables, we have all of these variables. Under socioeconomic variables, I have this. Now, with the use of canonical analysis, we can actually, maybe we can say that, oh, violent crime may be associated with poverty and unemployment and stuff like that. Okay, that is what we call dependencies. Does that make sense now? Now, I want to go into number 4, prediction. Okay, in this course, we're actually going to learn about uh, multivariate regression analysis. Of course, before you come to this class, you've learned about univariate regression analysis, where you only have one outcome variable. But in this class, you're going to learn about more than one outcome variable that we're going to call multivariate regression analysis. Of course, I'm going to walk you through the model, and of course, I'm going to walk you through how you can make a prediction using the model. Then we're also going to walk you through hypothesis testing. Okay, we're actually going to simultaneously, test, not just one parameter, you know, not just one variable, but more than one variable. All of that we're going to talk about in this course. Okay, so I think I've explained data reduction, the sorting, in the investigation, the prediction, the hypothesis testing, and let me now quickly come to this. Now, we're actually going to walk through algebra. You need the knowledge of algebra for this class, but basic algebra. Why basic algebra? we're actually going to talk about matrix algebra. Why matrix algebra? Because when you look at the nature of the data that you're working with in multivariate analysis, they are arranged in row and columns. Okay, you have them arranged in rows and columns, and of course, you know matrix algebra. Okay, we have rows and columns. So the idea of matrix algebra will actually be used in multivariate analysis. So when you take a look at this, if you take a look, this is the way my data X is going to look like. I have a data matrix X. Okay, if you take a look at this, if you give me 1 second, if you take a look at this guy, this is actually for column 1. The variable in column 1, maybe I'm talking about crime, a variable in column 1, then we're going to have data set across the observation. Okay, this is for variable 2, and here I'm actually assuming I have the n number of observation against the p numbers of variables. Now we're going mathematical now, and let me tell you this, it's going to be easy. What I just need from you is just for you to understand, to be able to relate this notation, the symbols to real life situation. So we're going to have it in matrix form, like I said. And of course, the dimension of the matrix is going to be n by p, where n is going to be the number of observations I'm talking about, and p is going to be the numbers of variables. Does that make sense? Okay. Now, if that happened, because everything is going to start from data matrix. Okay, everything is going to start from data matrix. And if I have my data matrix, okay, if you take a look at what I have here now, this is when I have a collection of a column vectors. The column vectors, I'm only talking about the variables. And this is when I'm talking about the collection of row vectors. If I'm talking about row vectors, I'm actually talking about the observations. Okay, so take a look at that. Oh my God. This is one of the example of a multivariate analysis. Take a look at this. Suppose that we collect n equal to 4, which is number of observation, okay, received from the university bookstore, and we record p equal to 2. In this case, p equal to 2. That means I have two variables, okay, and on the variable 1, you can see the amount spent variable 2. We can generate matrix on that, based on this right now. This is the matrix that we generated. Like I said, the idea of the matrix algebra is going to be used, well, because that will enable us to get the results on time when working with multivariate analysis. I think this is where I'm actually going to stop today. Now, I just wanted to listen to this before I go. There's an uncertainty. Of course, I know uncertainty occur in the world, but on Friday, uh, you should be expecting a message from me, whether the class will be held in person or we're going to be online on Zoom. Okay, so I'm going to send you the information. Like I said, there's flexibility in this class. Okay, whether you choose. So we're going to tell you, because I know some people are, they do kind of a strike on Friday. You've heard about it, but you know what? uh Expect a message from me, whether we're going to meet here or we're going to be online on Zoom this time. Does that make sense? Okay, that's what I got for you today. Make sure you all stay safe and have a lovely day. Bye for now, everyone.
And you know what? I've been expecting that.
Another.
I emailed you about it already.
Yeah. So looking to that, I mean that I would have so for phones, for also. So we saw.
What's that kind of? Do you really drive like that?
So I don't, but I do wanna drive.
I'm not even gonna, I'm gonna spam a flight for it. If I don't get one, there's gonna be a Best Buy up somewhere. When I get a job, it's terrible. Yeah, ideally when I get a job. I'm free. I'll do this.
I you had 41. I had 42.
How you doing? Good. Don't say it. Weirdest.
I had